Hello there, and then welcome to a brand new video. This is How Beyond Numbers, where we learn maths the easy way. I do hope you are doing well and then you are enjoying this playlist as well. In this lesson, we are on negative and fractional indices. So after it all, you should be able to simplify expression with negative index notations. And you should also be able to understand and evaluate fractional index. Without much I say, let's quickly go into it. So when we talk of negative index, we simply mean you have the base and then it is raised to the power a negative number. You see, you have the base, but then your power over here, or the index, or the exponent, is a negative number. So anytime you have anything of this sort, then we always want to work with positive index. You see, so you can change it to 1 all over the same thing, but then with a positive index. You see, so it is just 1 over the same index notation you have over here, but then change the notation, the power, to a positive number, and that is it. So you should be able to change from this side to this side, and then also from the left hand side or the right hand side to the left hand side, depending on where it is needed. You see, so simply put, a negative index simply means you are taking a reciprocal of the base. You get it? So let's look at some examples and then see how we can apply this law. So in this first question here, we have to simplify 2 raised to the power what? Negative 3. 2 raised to the power negative 3. And we have our base being what? 2. Then the index being negative 3. You see that? This here is having a negative index. So how do we go about it? We use this same negative index rule over here. So we should just write it as 1 all over 2 raised to the power a positive index. So instead of the negative 3, we are now writing what? A positive 3, as you have seen over here. That is the only thing we want to do. Then after which we can now evaluate. So you have 1 over 2 raised to the power 3 gives us an 8. And that is your solution. So it simply means your 2 raised to the power negative 3, when evaluated, gives you what? 1 over 3. As simple as that. I'll be solving more examples, and for each example, you realize that the level of difficulty will be increasing, and then you'll be seeing new concepts as well. So please stay tuned and solve as we move along. So this next one here, we have to evaluate x raised to the power negative 2. This one here actually just looks like this, but then it's a variable. So we have x to the power negative 2, and then changing our index to be positive, you're going to get 1 over x squared. As simple as that. This one isn't even different. Now let's look at one that involves a fraction. So over here, we have 1 over 3 all raised to the power negative 2. Now look at it carefully. Look at this one carefully. It is still the negative index rule. You get it? And then we said anytime we want to evaluate with a negative index, then let's find a reciprocal of what? The number or the base. You see, so if you look at our right hand here, it was actually x. The reciprocal of x is 1 over x. You see, so anytime you have any number at all, it is over 1. If you find if it's reciprocal, it becomes 1 over the number. That is what we were doing all this while over here. You see, so this time around, if our number is actually a 1 on 3, if it is a 1 over 3, then its reciprocal actually becomes 3 over 1. And you know what 3 over 1 is? 3 over 1 is still 3. Any number over 1 is still the same number. So applying that here, we say the reciprocal of 1 over 3, which is 3, and then we change our power to be positive. I hope you are getting it. All we are saying is if you have a base which has a negative index, if you want to evaluate it, just change the base to its reciprocal form. That is why x here, its reciprocal became 1 over x. And you have more here, our 2. Its reciprocal became 1 over 2. You get it? The same thing is happening here. 1 over 3, its reciprocal becomes what? 3 over 1. Then now the 3 over 1, all to the power the positive index. You see? So evaluating it now, we know 3 raised to the power 2 simply gives us a 9. So it means 1 over 3 all to the power negative 2 is a 9. As simple as that. So that will be it for this particular session on our negative index. Let's now look at fractional index. Talking of fractional index, the rule regarding fractional index simply says that if you have any base that is raised to the power a fraction, so something like this over here, so I have a to the power 1 over n, then it is simply the square, the root, the nth root of a. You get it? That is, for this one here, is if my numerator is 1. It is also applied when your numerator is not 1. So if you have a to the power m over n, so it is just the same nth root. Then you have a to the power m over here. You get it? So this second one is just an extension of the first one. This one here, the power is actually 1. You see that? But then this one, it is the m isn't 1. If your numerator is not 1, you are going to use the second one. If your numerator is 1, there isn't this first one here. But they all say the same thing. So simply put, a fractional index means a root. A fractional index simply means a root. And the denominator is always the root. Your denominator is always a root. What do I mean by a root? This here is a square root. A square root simply means you have a 2 over here. But most of the times we don't write the 2. You see, this here is a cube root because there is a 3 here. This is the 4th root in that order. So the number you put over here depends on what you see over here. You see, so if my denominator is 2, then I'm going to use a square root. If my denominator is 3, then I'm going to put what? A cube root. And then if it is 4, so whatever it is, you are putting that as the root over here. Then we come to the numerator. The numerator always affects the base. You get it? So the numerator is always going after the base. For the first one here, the numerator was 1. Hence, we have it here. You see, if the numerator is anything apart from 1, you still have it there. You get it? So let's solve some questions to see how we can apply these laws. Now, in this example you see here, we have to evaluate 16 raised to the power 1 over 2. And take note, our base here is the 16. Your exponent is a fraction. In this case, it is half. Now, using our rule, so let's use this as our general rule, you see. So we write our base, then we bring our root sign. Now, as to what root we want to refer to will depend on the denominator. So our denominator here is 2. Hence, we are looking at a square root. And as I said earlier on, if it's a square root, we don't necessarily write the 2 over there. Let's leave it as it is. Then our numerator here becomes the exponent of the base. Now, if it is 1, as I said, we don't write it, because any number to the power 1 is still the same number. Hence, we have the square root of 16. And we all know what the square root of 16 is. So the square root of 16 is just what? 4. As simple as that. This is when you want to apply the fractional index rule. But you realize that we also learned of the power of a power. So if you wanted to use that, then you can say 16 raised to the power 1 over 2. Now you already know that 16 from our introductory video, 16 can be written as what? 4 times 4. And 4 times 4 is simply what? 4 squared. You see? So instead of 16, you can choose to rewrite it as your 4 squared, this all of this, which is your 16, raised to the power 1 over 2. You see that? Now, the power rule says if you have anything of this sort, then let's multiply the index. So that I have 4, then the index multiplying each other is going to give you a 2 times 1 over 2. From fractions, you know 2 times 1 over 2. This 2 here is going to cancel out this ones. And all this when evaluate gives you 1. You see? So we are going to get our 4 raised to the power 1. And any number raised to the power 1 gives us the same number, which is the same as what you have over here. So depending on the understanding of the rules, you can always answer the question to suit your what understanding. You get it? But you have to make sure you are doing it right. Because if you are really using the rules, you should get the right answer. Now, I wouldn't ask you to master one over the other. They are both helpful. And if you understand them both, sometimes they all become necessary and helpful in their own way. Let's look at this second example over here. So we have 27 that is being raised to the power 1 over 3. You see? And if you want to use our fractional notation, our fractional index rule, then this here simply means our 27, which is our base, would have a root sign on it. Now, the root sign, is it a square root, or a cube root, or to the fourth root, or whatever it is? That depends on our denominator. And this time around, our denominator is 3. So we are looking at the cube root. The cube root of 27. 1 over here becomes our power of 27. But because we know any number to the power 1 is the same number, we don't write it. Hence, we have the cube root of 27. This simply means if you want to use this formula, you should know what cube roots are. Now, the cube root simply means what number multiplying itself 3 times will give you 27. And that is 3. Because we know 3 times 3 is a 9. 9 times 3 is a 27. So the cube root of 27 becomes 3. And that is our answer. Now this, though simple as it may look, it means it requires you to understand what cube roots are. On the other hand, if you wanted to use the power or the product of a product rule, then you would have said you have 27 raised to the power 1 over 3. Now you want to write 27 as an index notation. What I always say is, what you have here as the denominator should give you a clue of what your power on this should be. So if 27, then we are asking ourselves, we want to evaluate so that this denominator will vanish. It can only leave if you multiply it by 3. Hence, what number times itself 3 times is going to give you 27, and that is 3. So we have 3 times 3 times 3, which is what? 27, which is actually 3 raised to the power what? 3. Now we are going to replace that with our 27 we have over there. So that instead of 27, we'll rewrite it as what? 3 to the power 3. Now this is our 27, and it is all to the power 1 over 3. You get it? The power of a power says if you have something like this, then let's multiply the index. Let's multiply the what? Index. So then we are going to get 3 raised to the power 3 times 1 over 3. And by so doing, 3 times 1 over 3, we know the 3 cancels out the 3. We are left with what? A 1. So at the end of it all, we are going to get 3 raised to the power 1. And any number raised to the power 1 is the same number. Hence, our answer is 3. As simple as you see. You see, this is if you want to apply the previous rules we have looked at. As I have said, I wouldn't ask you to master one over the other, but their understanding are both necessary for what? Your evaluation of questions. Let's try this last one here as our last example. Now you can pause and then just try your hands on it. So this time around we have what? 8 raised to the power 2 over 3. And this simply means you have what? An 8. Because there's a fraction, it means we need the root sign. Now, what root is it we are talking about? Since our denominator is a 3, then it simply means we are talking of a cube root. You see? Now, take note, your numerator is not 1, but then it's 2. That goes for your base. So, indirectly, you are looking for the cube root of what? 8 squared. Now, you know 8 squared gives us what? A 64. So you can rewrite this. So that you are going to say we are looking for the cube root of 64. Cube root of 64 is saying what number times itself 3 times. You see, it's giving you what? 64. And that is 4. Because 4 times 4 times 4 gives us what? A 64. So the cube root of 64 is what? 4. As simple as it is. But if you don't know what these cube roots are, you've not memorized or you don't have a calculator with you, then you would choose to use the power of a power. So then you are going to write your 8 raised to the power 2 over 3. As you already know, as I have said, your denominator is what? 3. So always try and look for a number that is also raised to the power 3 so that you can cancel out the denominator. What number raised to the power 3 gives us 8? You have 2 to the power 3. So this 2 to the power 3 now becomes our 8. So this is 8 to the power 2 over 3. We have just rewritten it. This 8 over here is what we have as our 2 raised to the power 3. And nothing has changed. Over here, we now apply the power of a power rule. So that we have 2 raised to the power 3 times 2 over 3. And you know 3 times 2 over 3 from our fractions. That this 3 cancels out to this 3. And then you are now going to get what? 1 times 2, which is 2 over 1. And 2 over 1 is simply what? 2. So all of this here is going to give us a 2. Hence we have 2 to the power 2. And 2 to the power 2 we know gives us what? A 4. As simple as that. These answers are all the same. You can take any you think you understand. This comes to the end, or this brings us to the end of this lesson. I know it was long, but it was worth it. and I do hope you understood all that we did. If you didn't, you can kindly go over or take your book and then look at the examples you have in there. All we are saying in this video is that the negative powers means what? The reciprocal. Then for fractional index, it simply means the root. You see, but you would have to be combining some of the rules to help you solve some of the questions. So here you have two questions you can try just to test your understanding. This one is on the index, the negative index, and then this here is on fractional index. Let's have beyond numbers where we learn maths the easy way. I do hope this lesson was helpful. If there's anything, you can always let me know at the comment section and I'll address that when I do see it. Happy learning, stay blessed, and then bye.